So this is how it looks. Let's actually play this out. I know this is not maths, but I'm going to draw some graphs for you, okay? Because that's the easiest way to illustrate what's actually going to happen. So I'm going to draw these kinds of graphs, and you might like to draw a few as well, okay? What I've got on the vertical axis is the signal, okay? Like a sound or something like that. And on the horizontal axis, I'm going to have time. So there's the start of my signal, and here's, where it progresses, okay? So, what might things look like? What's the carrier signal? Well, it'll be some agreed upon kind of signal. Like for us, it's that hum at a particular tone. You pick it up, you recognize it. It might look like this, say, Okay? And when the computer who wants to transmit data looks at the bus, right, looks at the medium, and it sees this, it knows, great, there's a carrier signal, I can send some data. Okay? I can send some data. If, of course, it was just a flat line, right, it would know, okay, something's wrong, there must be an error, all right, and I can't send data. What does it look like when it sends some data? Well, we're talking about zeros and ones, right? So let's say it looked like this. Okay. So there's a signal, okay, and off it gets sent. Okay. That's all fine. The signal ends, and it goes back to the carrier signal. So far, so good. Okay. But what happens if there are two different nodes? Okay, and they both sense the carrier signal. They both hop on and they see this, so they're like, "Sweet, I can send." But they both send at exactly the same time. Okay. Why is this a problem? Now, by the way, I said exactly the same time because if someone had started sending a signal first, right, they didn't send it at the same time. Say you were sending, and this is what, and then I want to send. When you're sending, this is what I see. So it's a bit like, at home, right? If you've got multiple phones connected, home phones connected to the same line, and you're like, I need to call my friend. So you pick up the phone, but you don't hear the dial tone, you hear someone else talking. You're hearing an actual signal, right? Then you know if I start pressing buttons, nothing will happen, right? It won't actually transmit because there's no carrier signal. Okay. So problems start up when two people pick up the phone at exactly the same time. They both hear the carrier signal. So they both think, cool, I can transmit. Are we all on the same page so far? Okay. All right. Now, what happens when two people go at the same time? Okay. Well, the signal's not going to look like this. Okay. Because two people are adding signals at the same time, the resultant signal will look sort of nonsensical. Okay. It won't follow the rules of a normal signal, which is nice and sort of orderly. Okay. It won't be zeros and ones. It'll be all kinds of weird things which it's not expecting. Okay. So what's going on? One or both of the nodes will sense, this is not right, this is not what was meant to be sent, okay? And so what they do is they send out a signal, a particular signal, like say, a very long break, okay? Someone will realize, okay, I'm going to stop, right? Because this is not the signal I wanted to send. And someone else will say, okay, look, I'm going to send out a signal which basically says, it's a bit like a whistle. Everyone stop! Everyone be quiet, okay? Because obviously we're not getting across our messages. Someone needs to wait their turn, okay? Someone needs to make their phone call first, and then the other person will do it. And that's what this kind of means, the signal over here. It's a shh, stop, wait. Okay? Now what happens after that? Well, at home, what you can do is, after you both realize you've both tried to dial at the same time, right? You can say, hey, hang up, you wait, my phone call's more important. So you have a discussion with these people, right, who you had a collision with, and then you'll come to an agreement over, how you can, someone's going to go first, and then can you just wait 10 minutes, and then the other person will go, right? But the computers, the nodes on our network, they have no such luxury. Why not? Why can't they do that? Why can't they just talk to each other and say, hey, can you just wait for 10 minutes? Why can't they do it? Yeah, Ricky. Okay, so number one, we're talking simple devices here. right? So they don't have really intelligence per se. We need something automatic that can be just done, okay? So number one, there's your problem. It requires a lot of intelligence. Number two, how would they communicate? How would they have that discussion? Well, for us, you'd hang up the phone, and then you'd go over to them, and then you'd talk to them and say, hey, stop being a jerk. Let me use the phone first, right? Now, what are we assuming? We're assuming there's another medium, a second medium. Not the phones, which are messed up, but in our case, it'd be air, I guess. That's the other medium we can use. Okay? But here, for these nodes, there's no other medium, right? So it'd be a bit like, at this point here, if they're trying to talk to each other and say, I'll wait, no, you wait, and all that kind of thing, right? They're going to cause the same problem. They're just going to cause more data collisions when they talk to each other, okay? So we need some kind of automated procedure, that's what Ricky was mentioning, which can work on this network here, okay? Without the need for an extra medium. So what do? What they do is, at this point here, after all of that garbage is finished, okay, the two different nodes, they wait a random time. Okay, so this is set in the protocol, right? They look at their own computer's clock and they pick a random time, like say 5 milliseconds or 10 seconds or whatever it is, okay? And then they both wait the random time. So the carrier signal will return, okay? And then after the random time, they start transmitting again, okay? So say mine was 5 milliseconds and yours was 10, okay? I wait for my 5 seconds to elapse and then I start to send the message that I really wanted to send. Okay. Now after your 10 milliseconds, right, my message has already started, okay? So then you can't jump on and listen because you've got no carrier signal like you had before. So you just wait until I'm finished, the carrier signal resumes, and then you go off and send your message. Does that make sense? Now what would happen if at this point, after you've waited, you get your carrier signal again, we get another data collision? What would happen? It just repeats, okay? And this happens a lot, okay? This happens hundreds of times in a normal data transaction, okay? But, can you see, this is the procedure that nodes execute, this is what they go through, this is their process. When there's simultaneous transmission, do you get that, right? It has to be at the same time of data from multiple nodes, okay? And I just had 2. If there was 20, right, the same thing would happen. At this point, all 20 of them would wait a random time. Okay, and then hopefully the first person who has a unique time, they would start, and then the rest of us would lose the carrier signal, so we wouldn't transmit. Okay.